Hey guys, Ms. Pipel here. In this video, we're going to review some basic properties of acids and bases. So here are some lists of properties of acids and bases. If you remember the pH scale, it is a scale from 0 to 14 with kind of our midpoint of 7. So acids have a pH less than 7 and bases have a pH greater than 7. Acids do not feel slippery, while bases actually do make your hands feel slippery. So a lot of soaps would be considered bases. Acids, if you were to taste them, taste sour, where things that are more basic tend to taste bitter. If you've ever gotten soap in your mouth, you'd know that. Acids react with metals to form hydrogen gas, and that occurs in a single replacement reaction. And bases do not react with metals. Acids, their formulas always start with hydrogen, and for our purposes, bases are going to end with a hydroxide ion, an OH ion. So with those definitions, let's go ahead and identify acids and bases. So HCl, that starts with an H, and so that's going to be an acid. NaOH ends with OH, and so that's a base. This over here, this is acetic acid, actually, if you guys remember from our lab. So this also starts with an H, and so that's an acid. And then BaOH2, that is barium hydroxide, and so that is a base. So we also need to recognize that acids and bases will react with one another, and they specifically react in what's called a neutralization reaction. And neutralization means they create a neutral product. So when we talk about neutral, we're talking about a pH of 7. Okay, the thing that has a pH of 7 is water. Okay, water is the most neutral. It is both an acid and a base at the same time, because if we were to break it down, it is HOH, hydrogen hydroxide. Starts with hydrogen, ends with hydroxide. So both an acid and a base, and therefore it has that neutral pH of 7. So if I have an acid starting with H, reacting with a base ending in OH, it's a double replacement reaction, and we form water and a salt. The salt is the ionic compound that is formed, okay, and water is the neutral aspect there. Okay, so double replacement reaction occurring between an acid and a base, and this is also listed on your reference sheet as well. And the last thing we need to look at in terms of properties of acids and bases is their strength. Okay, we can refer to an acid or a base as a strong acid or base or a weak acid or base. Okay, acids and bases are generally going to be solutions, right? So they are solutions, they are dissolved in water. So they are aqueous solutions. That's generally their state of matter. And so we talk about strength, not necessarily in relation to pH or anything like that. It really is based on how much those ions dissociate in water. So a strong acid or base, those ions completely separate. So HCl completely breaks apart into hydrogen ions and chlorine ions. And you can see that in the beaker labeled A down here. You have completely independent ions, H plus ions and Cl minus ions. In beaker B, we see an example of a weak acid where you have hydrogen with nitrite, and you have a couple of hydrogen ions separated, but most of them are still together, so it's an incomplete dissociation. Okay, so they do not all separate and become completely independent of one another. They might stick together and still be dissolved, but they are not separated out into ions. Okay, acids and specifically acids can behave kind of weirdly. They're not always completely ionic compounds or completely covalent compounds. They kind of float in this middle ground, and so that's where strong and weak come in. Strong would mean it would act exactly like an ionic compound when dissolved in water and completely break apart. Weak would mean it's more leaning on that covalent side, and so not all of those ions break apart, and they might actually stay bonded together. So make sure you have all of these notes written down, and we will answer any questions you have in class.